Okay, all of you listen here. Good morning. So we are in the process of understanding the IoT agriculture process, and we have seen one of the case studies. Is that first case study what we have seen? What was the first case study? Agriculture. In agriculture IoT, the first case study what we have seen is leaf area index, LAI. So in LAI, how to measure the LAI? What is the architecture framework? What are the softwares required? How to build the entire architecture for that? What are the hardware required? All those things we have understood. But how do you do the analysis process also? Okay, next we'll be understanding smart irrigation management system. See, you know that in agricultural land, irrigation plays a major role. And it is very important for us to make sure that there is not too much of irrigation taking place or too less. Also, so we have to make sure that it is optimum and the plants are getting the sufficient water content for their growth. So we have to make sure that the land is not getting dry or we are not pumping too much of water. It has to be automated. The process has to be taken care. So in smart irrigation, we have to make sure that the water level, moisture, fertilizers and soil temperature all are as per as required or essentially what is required that is given to the plant. So what you need to do? You need to make sure that the farmers come to know all these things and the data, what is required, it is collected from the land as and when it is required. And there is no excess of wasting of water. And you know that water is a very important resource for the living. So you make sure that you have to not unnecessary waste water or damage the crop by putting lot of water into the farmland. Okay, so that is very important, and efficient and optimization of water supply is very important to keep the crop healthy. You can also see that the research carried out in the IIT Kanpur, Kharagpur, what they have done, they have taken a small portion of the land and they have implemented the water supply management system. So where their primary objective is to provide a web-based platform for the farmers where the people can monitor and monitor the water resources, and they can also make sure that the process is done properly. Okay. So what they are going to do, the farmers can take the necessary decisions of agricultural field, and also the concept behind the background agriculture, whatever it is to be considered, they can make the entire study of that process. So what these students of IIT they have done is, they have taken the entire land space and they try to implement this in the real-time scenario and find out whether this happens properly or not. So this you can also do it in the real-time scenario if you are interested in the college, where we can manufacture the entire resources for agriculture, and you can make sure that you can monitor the process by understanding whether the water is required for the plants and not. So if you are interested as a set of students, I am ready to give you the space for doing that project. Okay. So this can also be monitored. So this is how the entire architecture will look like. How the entire architecture will look like. See here, in this you can see that the architecture of how to irrigate the land. So what you can see there, what all things are available? You can see there are sensors available. So you can see that there are different sensors available. All the sensors are connected to the cluster head, and you have the processing board also. You can see that These are called as a moisture sensor. These are called as the soil moisture sensor, and you can also see the water level sensor, and you can see that these sensors are connected to the cluster and then processed further to the processing board, and you can see that it is connected to further to the server, and finally you get it in the handset whatever you are using. So you can make sure that you can monitor that if what will happen if the water content goes beyond. So the water level indicator will inform that the content of water required for that plant is beyond the limit. So you can make sure that the water gets stopped automatically. So this study was done, and they have also done a study on the automatic process as well as the manual process. For example, now you take one square of land, another 1 meter square of land, and you see that here you do the entire automation process where you connect the sensors, moisture sensor, agriculture, or whatever related sensors are there, water level sensor, all those things you connect it here. Here you do the normal mode of agriculture process where you go and go in there, give the water facility and all by manually. Here everything is automated, here everything will be manual process. When you take the entire productivity of the land, after 6 months or so, you can observe that since it is optimized process, you get the more productivity, and you can also see that the fertilizers required for the plants was done in a proper manner. Okay. In the other case, you may not know that whether the water content is less or more. You just give some water and you leave it. Okay. Sometimes it may be less, sometimes it may be more in the case of manual mode of operation. You also don't know that the fertility content whether it is enough or they are looking more fertilizers for that. Sometimes you can observe that if you put more fertilizers also, the damage will happen for the plants. So those things can be monitored and observed with the help of automation process. So we are going to see that sensing and actuating layers. So what you can see here, the sensing each parameter is very important. So what you can see is the sensor nodes, actuators, and all this are connected to the communication module, and each of this is connected further to the cluster and servers and all those things. So what is the advantage? You can whatever information you are collecting, you are going to pass it for the next operation. So you can see that. So they have designed. So we are taking that some of the students of IIT have designed for a certain land area, and what are the things they have done? They have used Zigbee, and they have used general package GPRS. So all these technologies they have used in order to communicate from one end to another. So down the line, they use all this EEPROM, and then they have also what will happen. See now how they will design that process entirely for that time. You have some sensor. So now the sensor will collect the information and it will pass on further. When the sensor will collect the information and pass on, you set up a threshold voltage. Threshold. For example, now if I say that this is the farmland, for example, let us see. This much is the water content which has to be there. So you will be keeping the sensor for that. So once the water level crosses to that beyond level, so that either an alarm system has to be raised, or you have to give a indication that there is a excess of water being pumped in. So the water will get stopped by itself. Okay. So that is the process which will take place. You can also try as a mini project this thing. You can take a small land area and you can one of the video I have shown you in the previous class, isn't it? So where they have taken and how they have keep the sensors and measure the water level and all those parameters in that. So this is one of the standard moisture sensor EC05. And you can utilize this process in order to find the moisture content of the land. Okay. So this is as a case study we have given there. So this is the processing and service layer. So what do you mean by processing and service? What is processing and service? What for processing is required? See, you get some raw data from the sensors. So it has to be analyzed and monitored, and you need to make sure that all this comparative analysis is done, and you need to find out that whether that whatever the it is taken, it is what is the use of that data, and until and unless you make it productive, isn't it? So that data will be collected and it will be passed on through the processing board. You can see a Zigbee attached to that as well for the communication purpose. So depending on the sensing values, the sensor nodes the pumping of water or whatever it is there, it can be initiated or it can be stopped. So that is what here these boards can be used for this purpose. Now you have used Arduino boards and Raspberry Pi and all those things, right? So similar to that. Then we have application layer. So what is the application layer? What you have studied in the first module and all, isn't it? You have studied OSA different layers and all those things. So application layer, you can see that the farmer has the status whether the pump is switched on or off, or the soil parameters are there. It is also going to display on the LCD screen that what is the status. You might have done in some of your projects also. So it is going to give that LED array or LCD screen. You can use it in order to track that whether the content, whatever, means you can make sure that it is easily tracked and it is user friendly for you. You can use the control of entire process with the help of a proper circuit. So this is what you can do it in that, wherein you can monitor the entire process without you involving into the system. Okay. And wherever you are, you can do this process. It is not necessary that you have to be very close to the field. If you are somewhere far, you are sitting in a classroom, still you can monitor the farmland by just observing your mobile phone. Okay. So that is the technology that it has advanced as of today. So what the deployment, that's what I have told you. These IIT students, what they have done is they have deployed in a certain, they have taken a certain square meter of land and they have tried, and they found that they divided the land into 10 equal halves, that is 3 cross 3 meters square, and wherein each system was deployed for 4 sub fields. So what they did is they took they made it as 10 subfields with the land. They made it as 10 subfields. In that 4 of the subfields they make sure that it is automated. It is IoT is involved in it. Technology is involved in it to monitor and execute the process. But in the other 6 portion, they were doing manual irrigation process as well as manual process, and they compared. They did the comparative analysis of this 4 with the 6 stocks. Okay, and they also studied that how the crop productivity is all about and how the irrigation happened for a duration of time. So this is the observation what they have found, and they found that when there is a technology involved in it, so we can, what are the advantages when the technology is involved in it? So yeah, so the advantages what they found when you are doing the automation process is, one is you are optimizing the usage of resources. The main important thing, you are not wasting any resources simply, or you are optimizing the resource utilization. The second thing what they would have found, they found that there is no much labor involved in it. You can cut short the labor cost. Then third thing is that what is the need for that plant is giving, whether it may be fertilizers or it may be water content, whatever it is, the plant is giving the sufficient content for its growth. And when you go with the productivity also, it was found that the productivity of the crop is far better, or it is going to give better production as compared to the manual operation. So these were some of the advantages. Still, there are a lot of advantages. It is user friendly. It is cost efficient. So many advantages are there. Where the farmer is going to be beneficial and being an engineering student or an engineer of the future, you can also contribute in this domain so that some of the other farmers of your area will get benefited out of your knowledge. Okay, so that is what the contribution you bring to the society. So you can take as an experiment, you can take a small portion of your land near to your home, and you can try experimenting by connecting the sensors. So that is what is the motivation factor for you. You can try that how you can connect to the pump and check whether that land is getting any productivity. See, now you do it in the first year itself. You can take it even for the 5 year project. Okay, where you can do the cloud interface and all those things you can take it to a very big level. So which the projects they are done in the IIT level. So you can also do it for your main project or mini project. So what you have to do is whatever projects you do, you need to do it with the real time scenario and test it. Okay. So that is what is required. So this is one of the case study what we have understood for the IoT in the field of agriculture. Okay. Now we will be seeing some more case studies in the fifth module. What are the case studies available for us to understand in the fifth module? We will be discussing on. So this is all about the fourth module 4. So we have completed module 4. We will be moving on to module 5 in the next class. So wherein we will be discussing on vehicular IoT, means the role of IoT in vehicles. Then healthcare IoT, that is very important as I have discussed before also. The importance of IoT in the case of healthcare. And then we will also go with the IoT analysis and all those processes. Okay. So this is what today we are going to what is the project? Yeah. Today so this is all about the module 4 and let us now have a discussion on biometric attendance monitoring system which they have students have prepared as a project and let us see how the project goes on. So now you can have the presentation over here. So we'll be starting the fifth module in the next class. So before that, some of the students have demonstrated some of the IoT-based projects. So today we are going to see one more project, which is on the attendance monitoring system. Okay, using fingerprint. So attendance monitoring system using fingerprint. So it is a very good project, and if it is going good, we will try to implement with respect to some 5 to 10 students and try how this thing goes on further. If it is working out for 10 students, we'll see for 20, and further we'll do it for 60 students. So that is what we can see.